Hi folks, we're going to take a look at page 438, number 8. So here they tell us that a boat takes 5 hours to travel 60 kilometers up a river against the current. Okay, so let's start by that with that scenario here. All right, so if you're going against the current, that means that whatever represents your speed, okay, so I'll call this velocity of boat, the current is moving against you. Okay, so that means that the current is going to slow you down. All right. So if we want to look at the resulting velocity of whatever you're moving at minus whatever the current slows you down at, it tells you that it travels 60 kilometers in 5 hours. Okay, and if we're looking for the speed, well, it's the number of kilometers divided by time. Okay, distance divided by time. So here, the total speed here is going to be looks like 12 kilometers per hour. All right, let's just move that over so we can see it. In the second scenario, now on the return trip, okay, so you're now moving in this direction, but now you're moving with the current. So if this is, again, the velocity that your boat can travel at, and the velocity of the current, we assume, stays the same when we're coming back, now the current is moving with your direction, so it's going to increase your speed. Okay, so we're going to be adding these two velocities together. But in the end, but before we do that, let's look at what the resulting velocity is going to be. Now, presumably, it should be faster since the current is helping you out. So here you do the same 60 kilometers distance, but over a shorter amount of time, 3 hours. So the resulting velocity here is 20 kilometers per hour, not surprisingly longer. Okay, but the question is, how are we going to determine these individual velocities? All right, so let's see what happens in scenario 1 when we're against the current. Here, we said the velocities are going to be subtracting. Okay, so we're going to take the velocity of the boat and we're going to subtract the velocity of the current, which is slowing you down, and that gives you a total velocity, remember, of 12. Okay, and the second scenario, you're going to be adding the velocities because the current makes you go faster. And when you add the two velocities, you get a resulting velocity of 20. And so here we have our system of equations. Okay, so let's solve it here. So I think the easiest thing to do is to eliminate velocity of current. So I'm going to add these two equations together. So VB plus VB is 2VB. Negative VC plus VC gives me 0. So I've eliminated the velocity of the current. And then 12 plus 20 is 32. So that means that the velocity that the boat is traveling at is 32 divided by 2, 16 kilometers per hour. All right. And now in order to determine the other value, we just input this into one of the equations, and I think it's easier to input it into equation 2. So velocity of the boat is 16, plus the velocity of the current has to be equal to 20. So that means that the velocity of the current is 20 minus 16, which is 4 kilometers per hour. All right. So let's just do a quick recap. So in these types of problems, when you've got the velocity of the boat, velocity of the current, you keep in mind that when you're going against the current, you're going to be subtracting the velocity of the current, okay, because it makes you go slower. Whereas when you're traveling in the same direction as the current, you're going to be adding the two velocities because the current makes you go faster. And then we used our relationship between distance, velocity, and time, that the velocity is given by the distance traveled divided by time, because we're assuming that everything's moving at a constant velocity. Okay, that's it for this one.